Bottles of a certain carbonated drink are produced by a factory. The mean volume is 1.5 litres and the standard deviation is 15 millilitres. It is decided to reject all bottles which contain more than 1,520 millilitres or less than 1,490 millilitres. We want to know what percentage of bottles get rejected. If we draw a picture to help us understand this problem, here is the mean at 1,500 millilitres, 1.5 litres. We'll draw our normal curve, symmetric about this mean. Here is 1,520. Here is 1,490. And we're going to keep the ones in the shaded area. We're interested in how many we reject, but we can work that out if we work out how many we keep. X here is a normal distribution with mean 1,500 and variance 15 squared. If we look at the composition of this area, we can make it up using two areas. The area here from 1,520 down to the middle, and then using the symmetric nature of the curve, the symmetric point to 1490 is 1510, so we want this area as well. This area is this one, and this area is this one. So we're after the probability that X is less than 1520, and this is the probability that Z is less than 1520 take away 1500 divided by 15. So the probability that Z is less than 20 divided by 15, which is 1.33 to 2 decimal places. And if we look at our tables, this is 0.9082. We want the area shown, which is this, take away 0.5, so 0.4082. We're now after the probability of X being less than 1510. Remember, what we're going to do is 1510, take away the mean, and divide by the standard deviation. So this will be the probability that Z is less than 0.67 to 2 decimal places. Looking up tables, this gives us 0.7486. Since we want to take off this area, the area that we want is 0.2486. Combining these two areas, 0.6568, which is 65.68%. That means we reject 100% minus this, which is 34.32%. Clearly, this would be a silly answer in a real manufacturing process. In a real manufacturing process, the standard deviation is very much less, so a much smaller percentage is rejected.